So for this case, it will be 1 bar 1. Positive A, this point, and negative B, this point. That's also the reason why I say that bar 1, 1 times negative 1, you will get 1 bar 1. So these two are equivalent. So these two are equivalent. I repeat again. For 2D, I draw the unit cell. Okay, many unit cells. There are 4 unit cells here. And then this is A direction. This is B direction. Okay. If I ask you what is the Miller index for, I use other color. What is the Miller index for this plane, the green one? Of course, you say that it's very easy because it cross A, so A equal to 1, B equal to 1, so K equal to 1 over 1, 1 over 1, you will get 1, 1, right? For this one, no problem. However, if I ask you, what is the Miller index for this one? Oh, sorry, the other one, not. For this one. Then what's the answer? The answer is either bar 1, 1, or 1 bar 1. Why? Because if you remember, I said that in the concept of crystal, this plane is equivalent to this plane. And this plane is equivalent to this plane and this plane. Right? Repetitive. Okay? So now, if this plane is equivalent to plane 2, plane 1 equivalent to plane 2, then I can also identify what is the Miller index for plane 2, right? For plane 2, I think it is much easier because this is B and then this is negative A. Alright, so it cross B and it cross negative A. So cross B, 1, negative A, bar 1. So for this plane, it's this one. Okay, and I also can move this one to this one because it's also equivalent. Okay, equivalent. So this is A, so this is negative B. So it cross A and negative B. Okay, previously was, okay, this is for the case, okay, this is for the case of this plane and this is for the case of this plane. Okay, now I proceed to 3D. Okay, let's say now we have two planes here, right? This is the first plane, the first plane, and we also have the other plane, this one, the yellow color one. Okay, so these two planes are equivalent, and now I consider only the yellow one. Okay, yellow one. I can choose either one, right? Choose the yellow one. So I can actually move this point along the, okay, we have 3 intersection points here, right? We can move all these points along the A1 direction, A2 direction, or A3 direction. Okay, for this case, I move it along negative A2 direction. Okay, this is A2 direction, so I move it along A2 direction. So this point, I move it to here, so I put it here. This point, I move it along A2 direction, so I put it here. This point, I move it along A2 direction, so I put it here. Okay, so now I have a new plane. Okay, which is this one. I repeat again. Because the concept of the crystal structure, so the neighboring unit cell have exactly the same pattern and same property. So I can actually move the plane to the next unit cell. Okay, so I want to move the plane to the next unit cell, then I choose 3 point lah. I pick this 3 point. So this point I move it along negative A2 direction. This point I also have to move it into the same direction, negative A2 direction. This point also negative A2 direction. Okay, so now this point 1 will come to here, point 2 will come to here, point 3 will come to here, right? So we have these 3 points. And for this 3 point, everything become clearer. Why? Because we know that this is A1 direction, this is A3 direction, and this is negative A2 direction. Okay, so now it's intersect A1, negative A2, and A3. So intersect A1 equal to 1, A2 equal to negative 1, A3 equal to 1. So I get 1 bar 1, 1, which is this. Okay, if you move it in other direction, the other possibility answer will be bar 1, 1, bar 1. Because this one times negative 1, you will get bar 1, 1, bar 1. Okay, both answers are correct. Okay, so now I proceed to the second case. The second case, this one. Okay, we have also 2 planes here, which are equivalent. Now I only pick one of them. I pick this one. You can pick either one. Okay, I pick this one. So this one you have 3 points also, right? 1 point, 2 point, 3 points. So now I want to move this point, these 3 points along negative A1 direction. Okay, if I move along A1 direction, negative A1 direction, then this is 1. So I move to negative A1 direction, so it become this position. So this position, atom 2. So I move it along negative A1 direction, then it come to here. So this is atom 3. I move along negative A1 direction, then it become here. You can see that all the arrows are pointing to the same direction. Pointing to the same direction with the same magnitude. All along negative A1. Okay, so now I form a new plane at these 3 points. Right? This point, and this point. Same, right? This one and this one. Yeah, use other color. Okay, same, right? So now I want to determine. So this is A1 direction. This is A2 direction.